Okay, so today is the 19th of October, and we're going to talk a little bit more about these different characteristics of graphs, okay? So we're graphing. My pen is about to die. Rational functions. There we go. Okay, so we've talked about domain. We did not talk about range. So we've talked about domain. And so we're going to use 1 over x. This is our parent function. And we're going to kind of use that as an example. We're going to write down the example and then what it means. So in this case, domain x cannot equal 0. So the domain is whatever x can be. And we've got to remember that we can't divide by 0. Okay? So domain is whatever x can be. A lot of times it's all real numbers. Sometimes there's a specific thing that x can't possibly be. So that's domain. We talked about vertical asymptotes, which I cannot spell the word asymptote. Let's see. There we go.
Question.
Yes.
It says whatever x can be. Is that remember?
Yeah.
Okay.
Spell remember for me, guys. R-E-M-E-M-B-E-R. Thanks, guys. Okay. Vertical asymptotes. Vertical asymptotes, again, is very similar to what we talked about with the domain. Okay? So we need to know it's what we set the bottom equal to 0 and solve. Okay, so in this case, we're going to go x equals 0, so we know right there, that's my vertical asymptote, because we don't need to solve anything. Okay, now the real important part, because horizontal asymptotes are harder to remember. Horizontal asymptote. Okay. Horizontal asymptote really has 3 categories. Okay? So we're going to say n equals numerator. Numerator. And d equals denominator. Okay. So there's 3 possibilities. There's the numerator is smaller than the denominator. There's the numerator is equal to the denominator. And then there's the numerator is bigger than the denominator. So this we always have 3 possibilities. If the numerator is smaller than the denominator, your horizontal asymptote is always y equals 0. If the numerator and when I mean the numerator and denominator are equal, I'm always talking about the degrees.
Okay.
And the degrees are the what? Those little exponents. The little numbers. Like when we say squared or cubed or whatever. Okay? If the numerator and denominator's degrees or exponents are equal to each other, then we just say the leading coefficient of the numerator over the leading coefficient of the bottom, of the denominator. Okay? Do we remember the leading coefficient is the number in front of the variable with the biggest degree?
Yes.
Okay. Numerator is bigger than the denominator. No horizontal asymptote. Okay, so let's talk about for our parent function 1 over x. What's my horizontal asymptote?
You gotta wait behind you.
Okay.
Yeah, we'll go. Yeah, we'll go.
We've got 2 more vocab words after this, guys, and then we can start looking at the classwork. Okay. So, do you guys see any letters, any variables on top?
No.
No? That means we can't have any exponents, right? So, it's 0. My numerator's degrees are 0. Now, if we're looking at the bottom, do we see one letter?
Yes.
Okay, so if we, gentlemen, if we don't see an exponent with it, it's just to the 1, right? Okay, and 1 is bigger than 0. So my numerator is smaller than my denominator, right? Therefore, my horizontal asymptote for this one is y equals 0. Okay, so horizontal asymptote is one of the more confusing ones. It's probably, but we can play with this. All right. Now we're going to talk about zeros, which are also called solutions, x-intercepts, that kind of thing. Okay, zeros are the x-intercepts, where the graph crosses the x-axis. So here's where I'm going to get on my calculator. Let's make sure I can kind of show, oh, that's not going to work. Okay, so if you pull up your calculator and you go to a graphing page and type in your graphing page, oop, I need to clear mine first. Okay, so we're in a graphing page and we're going to put 1 over x into it. Okay, 1 over x. So if we look at it, it's wherever, so you're going to look at the top, the numerator. When you set it equal to 0. Okay, so if we take the top of 1 over x, 1 equals 0. That doesn't make sense, does it? 1 equals 0. So this has no zeros. Okay, doesn't have any zeros. Okay. All right, the last one we're going to talk about is end behavior.
Which way do we go?
End behavior, yeah, is the direction that it goes in. So in this case, shh, guys, you got to be quiet. I'm still working on this. Still recording. Right here, we're talking about end behavior. So it's the direction this is going. Okay? So if we look, thank you. If we look right here, as x approaches positive infinity, where is y going? What's happening with the y? So if I'm going to trace this, so I'm going along. See those numbers popping up? Yes. If I'm tracing this, it's going closer and closer to what? As x is going towards positive infinity, y is, look at the y values.
Y is going out.
What's y getting closer and closer and closer to?
0.
0, good. Okay, now we're going to switch to the other side. We're going to switch to the other side. Whee. Okay, so as x is going towards negative infinity, y is going towards what? 0. Okay, so let's get rid of this. Then all of them are going to be set up like this. You're going to start with this part right here. X approaches infinity, y approaches what? X approaches negative infinity, y approaches 0. So this whole part right here is going to be the same for every single end behavior. It's what y is approaching that changes. And I like to look at my graph to be able to do it. You can plug in bigger and bigger numbers to your equation to do it. So end behavior is where the y value is going as x approaches infinity and negative infinity. Okay, when you are done with that, writing these down, okay, you should have domain, vertical asymptote, horizontal asymptote, zeros, and end behavior. So you should have 5 things. Okay, once you have those 5 things down, we can go ahead and move to today's activity. Classwork, yeah.
Wait. Y value is going
As the y value is where the y value is going. As x approaches infinity and negative infinity. So where's the y value going as x is approaching infinity and negative infinity? 1 equals 0. No zeros. So this is for the above. This is for the zeros. So it doesn't have any solutions for this one. No x values, no zeros. Okay. So let's go to our classwork, which should be this paper. If you don't have it, come grab it. Right here. Rational functions, exploratory activity. And I'm going to start you off, and then I'm going to let you guys go on your own. I'm in the middle of teaching and recording currently. Okay. So we're looking right here. We've got this crazy function, y equals negative 3 x plus 2 times x minus 1 all over x plus 4 times x minus 5. We're going to put this in our graphing calculator. Okay? So let's put it in our graphing calculator. So your graphing calculator, if you're following along with me, still kind of looks like this. Here, hold on. Let me shorten this small. I think this is as small as it'll go. Okay. So I'm right here. So I'm going to hit tab and go up, and I'm going to delete this last one. And then I'm going to put that control divide again. So I'm at a graphing page, and then I hit control divide. And then I'm going to type in negative 3 parentheses, x plus 2, end parentheses, parentheses, x minus 1, end parentheses. Then I'm going to go down to the bottom here. And I'm going to put x plus 4, end parentheses, times x minus 5, end parentheses. Okay? Once you have this, I'm just going to hit, Jordan, please come back to the classroom. Yeah. And I'm going to hit enter. So you're going to get something that looks like this. Okay. Now, do you guys see right here? We crossed the x-axis in these places. Okay? So that's what it says when it wants to know when it crosses the x-axis. It is also the zeros. So it's -2 and 1, which, let's switch back. So we're going to go back to what the graph looks like, what the equation looks like. Right here, x plus 2 equals 0 would mean x equals -2. X minus 1 equals 0, which would be x equals 1. Now I'm going to switch back to the graph again. You ready? Oh, look, that's where those things are crossing right there. Okay? Oop, I don't want this. All right. So, those are my zeros. For which values does the graph not exist? It says, hint, we can check our table. So from the definitions I gave you, though, where do you think the graph can't exist? What would I do? That's like the vertical asymptotes.
Oh yeah, on the bottom of the
So if we have x plus 4 equals 0, x can not be -4. And x minus 5 equals 0 means x cannot be 5. Let's check on our graph. Let's check on our graph. If we look at the table, so we hit Control T, and it brings up the table. Let's look what happens when we have -4. Oh, see how it says that UN? That means undefined. And then let's look at 5. Ah, see how it says undefined?
Yeah.
Okay. So what is the end behavior of our graph? So we know we want to set that up as x approaches infinity, what does y approach? And as x approaches -infinity, what does y approach? Okay? So now we're going to go back to our graph.
0.
Okay? We're going to go back to our graph. All right. So I'm going to hit Control Table so it goes away. So as x is getting closer and closer to infinity, which way is y going? Y is heading towards 5, right? So let's look. If we hit Menu, Trace.
I is going to the right.
I know it looks all crazy. Here my graph is going to come back to normal in just a second. Watch it. Give it a second. Here we go. Okay, so as x is going towards infinity, what's y getting closer and closer to? So we're at -3 right now.
0? Wait, I can't say.
Where am I going towards?
0. 0. Wait, what?
See, look at the bottom. I'm not getting to close to 0 very quickly. What am I going to go towards?
I'm lost.
So look at just the y value. See how it's going up?
3?
I'm at -3. Okay, am I going to pass -3? Let's see.
No. This is going to be -3.
So I'm -3.1, 0. Where am I going towards? Do you see do you see
It's a straight line.
the F1 at the bottom? So I'm just looking at the second number, the y value. So it's going towards -3, towards -3, towards -3. Where do we think it's approaching towards? What can it cross? What's that thing that we did on there? There's like a horizontal asymptote, right? And what is my horizontal asymptote? So let's go back. What's my horizontal asymptote? Let's look right here. Are my degrees, oops, we got real close. Okay. Are my degrees the same on the top and the bottom? This is 1, this is 1, this is 1, this is 1, so those are the same, right? So my numerator and my denominator are equal, which if we look back in our notes means right there, that's our horizontal asymptote. So I'm going to tell you right now, it's not going to cross that horizontal asymptote. So let's look in the other direction for my end behavior. Let's look at the other one for my end behavior. Hold on one second. I'm just zooming out. Okay. One second. Okay, shh, guys. Yeah. So right here, I'm going to just re-enter my graph. Oh, hold on. I'm just going to do this. So if my graph didn't turn out right, I'm just going to hit B. I'm just going to go to my graph page, and I'm going to just re-enter it because mine got all funny. -3, I'm going to say x plus 2. We've done this before. Yours should still be there. X minus 1. All over x plus 4. Shh, stop talking. X minus 5. And I've got this graph right here. So right here, where do you think this end behavior is going towards? If we knew this one was going towards -3 over here, okay, this one is going where? Now remember, -3 is my horizontal asymptote, so I can't ever cross it. So where is this going? As x approaches -infinity, y is going towards? Let's look at the table. Hold on. Hit Control T and we can see a table. So we're going to go down. We want really, really, really far down negatives. So I'm going the wrong direction. Really, 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 really far down negatives. Negative, 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 negative. I keep going. What is it getting closer and closer to?
-2.
So if we keep going, am I going to pass? I'm getting closer and closer to what number? -3. So if we go back, remember it's that horizontal asymptote. We're going towards -3. We're approaching -3 in both directions. So I am going to give you guys the rest of the hour. I just want you to try 5, 6, 7, and 8. So you're just doing one more problem just like we did. Put it in the calculator to find these. And then your homework tonight is looking at these equations. Is looking at these equations, its characteristics, and figuring out the zeros, asymptotes, and end behavior. Okay? So I'm going to walk around and help right now with 5, 6, 7, and 8 if you have questions.